All right, so the first question I had was about question 15. And I'll show you how I would mark this. When you're marking the syringe, first of all, you know that you're going to draw regular first, NPH second. The other thing to keep in mind, and I'm going to show you this graphic here. Find it. Oop. So this is from a textbook for dosage calculations. And when you look at this, first of all, it tells you that you're mixing regular with humulin N. The correct way to mark the syringe is you want to draw, or you want to indicate the total amount. So in this example, it was 40 units was the total. The 10 units of regular that is drawn up first is going to be closer to like the plunger side of the syringe. And then your non-regular, so in this instance, it's humulin N. I think it's NPH in the other example, and I'll mark it. So if it were me, now that I can, that I'm seeing this, and I've seen this over now a couple of years, is I would put a little bit more detail and mark your syringe indicating basically where the NPH is, where the regular is, and then the total. So I'll show you how I would mark that in just a moment. So let me switch my sharing. So this is, I would indicate here that you're drawing up 10 units regular first. So I'd make that as, I would make sure I indicate that. And then I would also indicate, for the total for this, 50 units total. I would just make sure that you and your instructor knows exactly, that you know what's going on. Okay. So don't allow for any leeway with understanding. Then as far as marking the syringe, make sure you circle the syringe. We are going to mark at a total of 50 units. Our regular insulin is going to exist between 40 and 50. And then our NPH is going to be down here. So the way I would write this out is I would kind of put that there to indicate where the regular was, that mark there is the total, and then that the rest of this is going to be my NPH. So drawing it better than I am, that's how I would mark your syringe. So I would indicate, even though it doesn't tell you to indicate the NPH, I would recommend that you do that.
So I see how you did it now, and I had it like opposite. So I had like the 10 as the first 10 from like in the needle, going from the needle like to the plunger.
Yeah.
So that would be wrong, right? Because the regular went in first, which makes sense to me now.
Correct. And so
okay.
how you want to look at this, and then how you want to look at this is what would be the final finished product. After you've drawn everything up, what is the final finished product? And that's how you want to kind of set this up. So the final finished product is the regular is closer to the total side, and then the NPH is pushing the regular closer to the total. In reality, it all mixes together. So that's where I think this, at least for me, it's like, what? But when I go back to that previous graphic that I showed you from the textbook for dosage calculations, this right here shows you, and this is the textbook way of marking the syringe, or at least indicating on the finished syringe. So once all the insulin is in the syringe, this is what they're looking for, how to mark it.
Okay, okay, thank you.
You're welcome.
Wait, so that's only marked till 40 though. Is that okay?
Yeah, but this is a different question.
Like just an example. Yeah, okay.
Yeah. So like if it like on the previous one, it goes, the units go up to 100. And then they're by two increments of 2. This is just a different syringe that's in increments of 1. And then the examples for 40 units. So like if you go up to the question here, it says 10 units regular, 30 units Humulin N, and how would you mark the syringe? So this would be how you would do it. So in the example that instead of 30 units, it would be 40 units and then 10 units with a total of 50. So you would just move the plunger back essentially. All right, so for question 24, let me look and see. Oh, yes, that is correct. So the 300 milligrams, that's just what you would put them on afterwards. So if it said how many milligrams to administer, like on day 2, it would just be 300 milligrams. So you would only need to know the 300 milligrams per day if they also gave you like the tablets per milligram or the milliliters per milligram. So you can then figure out how much to administer. But this question is really just asking you to convert pounds to kilograms and then multiply that number by 15. Ignore the 300. Question 19. Okay, so before I answer question 19, I think it's important because for 130, what's new for you guys this semester is the flow rate type questions. So the flow rate type questions. So let me just, I will definitely do number 19. Let me kind of introduce flow rates, and then I'll answer a couple of different questions with that. So, so a couple of things you need to know about flow rates. The flow rate is just volume over time. In nursing, we would indicate that as milliliters per hour. Or sometimes you'll see it listed as cc's per hour, but you know that cc's and mLs are the same thing. Additionally, you have something called a drop rate, which is going to be drops per minute. That's abbreviated GTT per minute. With flow rate, all we're trying to do is decipher what to plug into the infusion pump. So, as an example, let's say someone is needs to receive 500 milliliters of a particular IV infusing over 4 hours. So I want to administer 500 milliliters of a particular IV over a particular substance via IV over 4 hours. So the way I'm going to set this up to calculate a flow rate is I'm going to take the volume over the time, and I'm going to reduce 500 over 4, which comes out to 125 milliliters per hour. So for question 19, it's essentially the same thing. It says you have 375 milliliters of Ringer's lactate infusing over 3 hours. So what you're going to do is you're going to take 375 over 3, and then just you're going to put that into your calculators, 375 over 3, which is also 125 milliliters per hour. Now, what about if you get something that has like infusing milliliters per minute? So like one of the other questions here is on question 17. It says to administer 120 milliliters in 90 minutes. So when you do that, you're going to set it up exactly the same. But you need to do one additional step. You need to convert minutes to hours. Alternatively, you could say, because you know that 90 minutes is the same thing as 1.5 hours, you could set it up that way as well. So if you did it that way, you're doing it right. So 120 times 60 divided by 90 will give you a flow rate of 80 milliliters per hour.
On the exam, would it be okay if I put just like 120 over 1.5?
Yeah.
I just did that. Okay. I didn't know if I needed the other work.
Nope. They don't really care how you do it. They just want you to show your work.
Okay. Thank you.
You're welcome. Now, when it comes to drop rates, in order to calculate a drop rate, you need two pieces of information. You need a flow rate and you need a drop factor. Those two pieces of information will give you your drop rate. So as an example, let me go back to the practice test. I know 19 was asked. If I worked 20 out in the first review session, so I'm going to go ahead and do 16. And I did 16 on Tuesday's sessions as well, but we'll do this again. Actually, no, yeah, that's what we'll go ahead and do 16. So it tells you, that the order is the dextrose 5% water IV solution at a rate of 75 milliliters, 25 minutes. What is the flow rate in drops per minute if we have a drop rate of 15? So when we're looking at our labels, it tells us what the drop factor is, which is 15 drops per milliliter. So my flow rate, usually flow rate is milliliters per hour, but this one says 25 milliliters, 25 minutes. If it's in minutes and you're calculating a drop rate and you're calculating for drops per minute, please leave it as per minute. Do not convert that to hours. Times the 15 drops per milliliter. You can plug that into your calculator. 75 over 25 is 3 times 15 is 45 drops per minute. If you do this, or if you're trying to do like ordered over half and you're getting stuck on this stuff, order over half doesn't work very well with these things because you have a couple of different variables. Technically, your known is 1 ml and you're looking and your quantity is drops. And so sometimes it gets to be a little bit of a challenge where dimensional analysis can be helpful with this. So, but if you're setting these up a different way and you're still getting the right answers, you're doing it right. Just make sure you're multiplying flow rate times drop factor, and you should get that correct answer every single time. All right, any other questions from the practice test or any other questions you might have?
Is the drop rate and the flow rate the only new things that are on the nursing 130
Yes.
test? Okay.
From what I can tell, those are the only two things, that are new for you guys. Yes.
Okay, thank you.
Remember, I think you had the reconstitution last time. So that's the same. And then this is just a matter of converting micrograms to milligrams. So I think,
Can you go over the reconstitution?
sure. So the biggest thing with the reconstitution is you just need to know that there's information here that's on the label that you don't need to worry about, and that's the milliliters of diluent added. That doesn't tell you how to solve the problem. You just need to know the strength. So the strength is units per milliliter, and then you just look at your three options: 250,000 units per milliliter, 500,000 units per milliliter, or 1 million units per milliliter. And then once you know, and it tells you to use the strongest concentration, you just take your 750,000 units divided by 1 million units times your 1 ml, and then you'll get your answer. And in this instance, it's 0.75. Where this comes from, and I'll show you. Show you a picture of a label. Go. So this is an example of Pfizer pen. And which is what we're using. Now it tells you that the total of the Pfizer pen is 20 million units. But if I wanted to know how many milliliters to administer, I need to look at the actual package. And so I turn the label over, and you can see here, these are the milliliters of diluent added to get to these concentrations, which is units per milliliter. So this area over here, the milliliters diluent added, just tells you, if you're the one mixing this, or the pharmacy, how much sterile water to add to get to these concentrations. Notice that the less water you add, the more concentrated it is, and the more water you add, the more dilute it is. And so that's why that is written the way it is. If you were at one of the other campuses, like Boyce or South or North, they usually have to ascertain the information from the label. And so this is where it's helpful to know where this stuff is. The other challenge is you have to be told which concentration to use, because technically, depending on which dilution you use, you would use a different milliliter amount. So that's why at least in the questions that I asked you was choose the strongest concentration.
So for those, for that question, I mean, the strongest concentration is just going to be, whatever option has the least milliliters of diluent, correct?
I would say don't even just ignore the milliliters of diluent. Don't even look at it. Just look at which one is the higher number units per milliliter. Yeah. Because if I tell you to do that, you're going to, I can just see, because I know I would do it, I would confuse myself as like, okay, low number, low concentration. Wait. Low number, high concentration.
Yeah. So we're just
ignore this section.
That makes sense.
Don't even look at it.
Okay.
Yeah. There. You only care about this stuff here.
Okay.
Question, by the way. 3. All right, so 23, 23, you know how to do. You're just going to take the Visceral 60 milligrams, divide by 50 to get your milliliters. of Visceral. Then you're going to take 85 milligrams of the Mepridine divided by 75 milligrams, get that ml, add those two numbers together, and that is how you do that question. You're just mixing two different medications, and then you're adding. The only thing that might be off is the key might be wrong. If I'm answering this question, 60 divided by 50 is 1.2. 85 divided by 75 is 1.13333 repeating. I'm going to add that to the 1.2. And I'm going to get 2.3333 repeating. So your answer for this is 2.3 milliliters. Just want to make sure that's the right answer. 2.3. So that's correct. Good question. Just double checking to see if there's any other questions that were asked earlier. Seen a lot of these before. Just remember when you're answering a question, make sure you, if it asks for teaspoons, that you calculate for teaspoons. So in this example, you would need to do an additional, additional conversion of milliliters to teaspoons. And then hopefully, as you recall, 5 milliliters equals 1 teaspoon, or 1 teaspoon equals 5 ml. So you can even just rewrite this as 125 per teaspoon, and it saves you a step when you're doing your calculation. And another thing that's asked is the fluid replacement. I'll show you, and I'll just briefly show you what that looks like, just because sometimes it's helpful to just see like a strategy for answering those if you struggled with that at all. So for what I've shown is, like, on that question, we have 3 numbers that you'll see consistently on when you are asked the tests asked to answer tests questions from or on your test. The things that can change are how much the patient actually voided, what the potential output would be. So like for every 125 milliliters of urine output, replace with. So that's considered your potential output. And then the replacement volume. All 3 of those numbers can change. So the formula that seems to work. And then when I initially did this, I just did like a ratio. So I set things equal. This is probably an easier approach to this. You're going to take the patient's actual output, 500 milliliters in this example, over their potential output, in this example, 125 milliliters, and then multiply by the replacement volume. And again, in this example, it's 40 milliliters. So 500 over 125 times 40 will give you 160 milliliters. That's how much you would need to replace fluid-wise after 4 hours in this particular example. The things that'll change, like I said, this number could be 100 milliliters. This number could be 250 milliliters. This number could be 100 milliliters, or it could be 1,000 milliliters. It just depends on how much they voided. And then that's how you would answer that question. Are there any other questions?
Nope.
So if there are, just go ahead and take a look through the test if you have any other questions. If not, like I said, I will have this posted on Blackboard. I'm sorry, on YouTube, probably later tonight. And then you could also review the Tuesday review sessions for 1:30, and as well as the earlier session from today. And I usually mark them as part 1, part 2. And then some people ask different questions. Sometimes I answer the questions a little bit differently, but for the most part, this is the review, and I've shown you what is potentially new that we'd probably see on the test next week. And if you have any questions between now and then, just you can always you can email me, or you can just let me know otherwise. So,
Thank you.
yeah, you're
Thank
welcome.
you.
You're welcome. Good luck on your
Thanks
test.
a lot. Thank you. Have a good night.
Thanks a lot.
Yep, you're welcome.
Thank you. Have a good night.
You too. Thank you.